A quick syntax example of the situation where constructors invoked. For instance, in Java code, we can have the stack constructed by the new operator. So in Java, every time you create an object, you're required to use the new operator. In C++, you can have different ways of instantiating the object, and using the new operator in C++ would be constituting dynamic object creation, dynamically allocating an object. Java programming language using this specific terminology, talking about object members versus class members. So basically, object members are variables that belong to a specific instance of a class, to a specific object, where class members belong to the entire group of objects that can be instantiated from this class and considered to be common to all objects. So this is class members. Class members are common to all objects. Its creation in Java programming language as well as in C++ is designated as static data members. Okay, so I'm not going to spend a lot of time doing it. Instead, I'll just give you an example of the savings account class that has a balance. It has an overdrawn state, which is a boolean that can be true or false. But the minimum balance is defined common to the entire group of savings account by the fact that it's declared static. So when we are making a change to minimal balance, we also have to make this method or operation inside this Java class. It has to be static. Only static operations can access static data members. And here we are taking new minimum value for the group of accounts and set the minimum balance, the static attribute of this class, to a new value. Non-static data member example corresponds to an object level data attributes, and of course when we have a savings account with specific balance, a balance would be an example of an object level attribute. Of course, every instance of an account with its own account number and so forth, other attributes specific to a user or organization who is the owner of that account, will have different balance according to the current state of the account. There are some rules that are applying to object level and class level data attributes, as well as methods in Java. So it says here static members can be accessed through an object. This is a typo. This should be saying class. So let me make a quick correction here. So this is incorrect. This should say class. Class, right? So static members can be accessed through a class, and non-static members cannot be accessed through class. Static members can be accessed through the class name. So, and examples are here invocations of the deposit and change minimum balance. You can use an object to an existing reference to an existing object in Java to invoke both static and non-static methods, but using class name can provide access to the static methods and static data attributes, but deposit, which would require an object creation, would cause an error if it's used with the name of the class. So these are just reminders from the rules of the Java programming language. So this is all specific to Java programming environment. Axioms of object paradigm are like rules that should always be followed without any exception. In general, each problem domain consists of autonomous objects. So you would like to represent the entire solution as a set of objects which interact and provide a certain level of functionality. Autonomous objects, autonomous meaning that they're independent. Ideally, every class should be designed as an independent concept, which means that, for example, in our case when we were talking about class name date, it's self-sufficient and does not depend on any other class or anything else in the system. Its entire declaration over here is self-contained, autonomous, independent, and completely fulfilled. That's the idea of the autonomous. So autonomous objects exist in space and in time and interact with each other. In space and in time, of course, space is some sort of memory allocation, but timely characteristics of object life cycle are also important because we need to recognize the idea that before objects can be used, they have to be created. And when you have various data types, you have to figure out in what order specifically you will create your objects. And that could be actually a challenging task and part of the problem solution. Interactions are operations invoked by objects on each other's behalf. And let's bring up the diagram that we used earlier to demonstrate interactions and operations invoked within model view controller architecture of the system that was trying to behave as a system that controls the climate control in the building. Right? So every time we've used new calls, those represent object creation. And then you see the method calls or function calls, depending what programming language you're using. But these are all operations that demonstrate interaction of objects that exist in computer memory. And of course, time-wise, you can see that when we start in our main function, at the top of this diagram, when it starts, none of these objects actually exist. The main actually creates them and populates them with initial value. Sometimes other objects are responsible for creation of other instances. It all depends on the application and all is specific to your design. So this is the demonstration of interactions and operations invoked by objects on each other's behalf. There are patterns or regularities in the structure and behavior of objects. So these patterns can be actively sought, and for instance, one of the demonstrations that we've used was this model view controller design, which we said would be a great idea to use in graphical user interface applications as well as web-enabled applications, as well as any sort of distributed applications with graphical user interface. So this establishes a pattern which in this case says that we need to observe certain rules when programming and modeling these classes. So that we said that one of the major rules is that the view should never interact directly with the model tier, whereas controller would provide a set of operations for any need when we have to cross the border between the two different tiers. And the idea of these patterns brings us to the conclusion that behavior of objects, the structure of objects, relationship between objects, and the interactions, which obviously correspond to what operations should be available on them, can be modeled. And modeling means that the solution can be found before we actually start programming. So that's the idea of the object paradigm and the design modeling, so that we can find certain solutions way before we start writing any single line of code. There could be, of course, situations where we need to find solutions by simply looking at possibilities by doing experimentation. So experimentation is different compared to modeling. Experimentation typically is a project which we can use to try different techniques, try new technologies, try different programming environments, and see what are the outcomes, the scalability of these things, and so forth. But this is not an end product implementation. Prototype or any sort of experimentation is a sideline project. But overall behavior, if we recognize certain patterns, the modeling can provide solutions to the problems before we even start coding anything. So the strength of object paradigm should be recognized, as in many cases it can be easier to understand and maintain. Of course, it still depends on the level of the problem, and there could be systems that have a poor design, and so they will be difficult to understand and maintain. But many successful projects with a solid design are actually quite open to further modifications, easy to maintain and understand, and the ease of understanding, of course, provides great opportunity for bringing new people into the project. Clear mapping between objects in the problem domain that helps to clarify problem solution, make it stronger. Support of reuse of objects in the model. There may be multiple versions of code reuse, component reuse, module reuse. This is a pretty big topic to discuss. And inheritance reduces redundancy. We have not spoken about inheritance yet, which is one of the programming paradigms available in object-oriented platforms. But there's also something to note here. If you know what inheritance is, it will, of course, reduce the redundancy, because in inheritance, the base classes will incorporate the functionality of the derived classes, and by using these derived classes, we make instant reuse of already existing functionality. Also, topic for a different day. And in summary, model design and implementation consist of interacting objects in object-oriented paradigm or set of principles. The objects are autonomous, which means independent, and have their state and behavior. Objects encapsulate state and algorithms. Algorithms are naturally represented by the operations exposed by the corresponding classes. And the algorithms are encapsulated inside the methods or functions in C++. Method is a Java term. C++ term is function or member function of a class. Procedural program, also to summarize, also is based on a set of principles. So the model design and implementation consists of interacting functions. And of course, functions refer to the classic environment of the C programming language. Functions share centralized state known as global state. Okay, so set of data is defined as a global state. And the emphasis on global here is that there is no other mechanism in C to restrict any access to existing objects, existing structures, rather than programmer agreements or conventions. So therefore, overall, it has to be viewed as global space where we can modify everything from every function. So function local state with its local variables does not survive their execution. That's one of the principles that, of course, carries on to object-oriented paradigm as well. Functions encapsulate algorithms. Global states are not encapsulated. By the way, you can use any programming language to model global state, but it's just that classic C programming environment does not provide any automatic management of global state and any sort of restrictions to the global state. Functions, of course, can cause side effects, which we also discussed, and sometimes it's a bad impact on the overall program design. So object-oriented programming principles offer some alternatives to these principles of the procedural paradigm. What to expect from an object-oriented programming language. This is, again, a lot of things to discuss in one time, but overall inheritance, we will discuss inheritance in the future. This is one-of-a-kind relationship between classes. Polymorphism provides dynamic environments and provides the possibility to dynamically control the behavior of our objects at runtime. In general, object-oriented environment would prohibit the use of global variables, and oftentimes the presence of a global variable would indicate some kind of weakness or compromise in the overall design. So the only variables allowed are the data members of classes. And no global functions, which is true and not true in C++. In C++, the rules kind of restrict themselves a little bit more, that use of general purpose global functions is actually encouraged. In Java, it is generally discouraged, and your methods should be only the functions or operations of specific classes. So this is very high-level overview of the expectancy from object-oriented environments, but we will be discussing this in greater detail later on in our presentations. And object-oriented programming languages, you can see that there are lots of different programming languages that have an ability for you to use advantages of object-oriented features. And of course, Java and C++ are at the top of this list, but there's also C#, Python, and so forth and so forth.